My name is John Morlock. I'm the Associate Director of our Engineering Education Transformations Institute. We run lovely events like this one. I am also the advisor for our Dean's Engineering Education Fellow program and the person who leads that program. I want to give a quick overview about it because we have two current Dean's Engineering Education Fellows here who'll be presenting about their experience. The Dean's Engineering Education Fellowship Program is a 2-semester program where students spend 1 semester teaching as instructors of record, a course within our college. Josh taught a section of statics and Andrew taught a section of data science specialization. Is that the name of the course? He'll correct me when he gives his presentation if I'm wrong. They do a semester of engineering education research. And you'll hear about some of their research projects here that they've been working on. Josh has been working with Drs. Farman and Ramasamy, and Andrew has been working with Dr. Kyle Johnsen. So this is a program that runs annually. The application cycle tends to be in late September, early October. So if you have a student that'd be interested in that experience, please keep an eye out for that as to that late September, early October timeframe this coming academic year. So without further ado, I'm going to pass it over to Josh Dunlap. Applause.
Is there a... All right, well, thanks so much, Dr. Morlock, for the wonderful introduction. For those who don't know me, my name is Josh Dunlap. I'm a doctoral candidate here in the College of Engineering, and of course, talk about my experience with the DEEF Fellowship. Unlike Andrew, who you're going to hear next, I did the teaching portion of the DEEF first. So last semester, I taught a course of statics, and then I'm currently doing the research component right now. And so, unfortunately, I don't have a lot of results to share research-wise. Hopefully, next time I come here, maybe I'll have a little bit more to share. But I do want to at least give kind of an overview of the research I'm doing. I think a lot of you will find it particularly interesting. And then rather than talk about my whole experience teaching a course, I kind of just want to focus in on one specific aspect that I implemented that maybe was a bit non-traditional, but it seemed to have worked well. So I'm curious to hear what all of your thoughts would be on that too. So of course, I'm doing research right now. As Dr. Morlock mentioned, I'm working with Dr. Ramasamy, and of course, under the guidance of Dr. Morlock. What we've been interested in is student experiences in online and in-person summer engineering courses. So specifically summer courses. We have 2 courses in particular that meet our criteria. So it's 2 courses that have both an in-person and a online component in summer that we're looking at. Of course, for Dr. Ramasamy, the kind of end goal is to improve the summer engineering course experience and the student experience in summer engineering courses. But in a more fundamental sense, what we're kind of interested in, is why are there such large disparities between in student performance between online and in-person versions of a course? And I think that this isn't really a shock to anybody, right? We know that online versions of a course tend to have a lot lower student performance. So we're interested in why that is. And, this question, it seems kind of simple on paper, but it's actually very complex, right? Because when you have an online course, are these differences due to more maybe inherent structural issues? Like, for example, in an online course, maybe there's less instructor engagement compared to, an in-person course. Or on the flip side, this could be more related to the students who sign up for courses, right? Maybe students sign up for online courses, they have different expectations, something like that. I know it wasn't that long ago that I myself was an undergrad. So just kind of thinking back to my own experience, right? There definitely does seem to be a perception that maybe online courses are, not necessarily easier or harder, but maybe less stressful right? Less intense than an in-person course. You kind of work at your own pace. I know I've definitely, probably signed up for courses in the past for those reasons. And the way we're hoping to answer this question is selecting specific students to interview. So we're hoping to interview students regarding their experiences, and hopefully we can shed some light on this issue. Before we did that, though, we wanted to make sure that these disparities between online and in-person courses, they're not due to things like the semester a course was offered, or maybe the instructor, or even course itself. And so we can start doing that by looking at the differences between the student grades and their overall student GPA. And I think you guys will find this really interesting. We can start visualizing this here. And so here what we're looking at, we have a specific course. We'll just call this course A. This course was offered in summer of 2020. On the x-axis, the horizontal axis, these are the, do I have a laser pointer? Yeah, these are the grades that students received in the course. We converted these into numeric values. So, an A is a 4.0, a C would be a 2.0, and so on. And then on the y-axis, we have the difference between the grade a student got in a course and their overall GPA. And this GPA is the GPA following the semester that they took this class. So this would be, in this case, the fall semester. And we can see some really interesting things. We expect, most students to kind of fall within these blue bars. In other words, think of students like a B, average kind of GPA student. We expect them to get, a B in a course and so on. And we do see that most of them fall into this range here, but we can see clearly really big differences between the online and in-person version of a course. Not only in online courses, there's a much greater variability in student grades, but there's a lot more data points here that are kind of below this blue line. And essentially what that means is these are students who there's a big deviation between the grade they got in a course and their kind of overall GPA. And so as we kind of move down to this left corner, these were students who essentially in, in an online course, maybe they didn't do well, but they had good GPAs. And clearly, you see a big skew in the online courses down to this left corner. We even have a student here who essentially failed the online course, but they were basically a 4.0 student. And then, these students here are like B plus, GPA students, and they still ended up failing this course. So that's what we're hoping to find out, right? We're hoping to, through student interviews, we can help find out why. Yeah. But this is just, one course, summer 2020. This holds across semesters. So here's same course next summer. See the exact same, trend. Same course, last summer. The instructor changed as well in the online course. So this trend also holds across instructors, and also it holds across courses too. So here's a second course we're looking at. And in this particular course, there's a little more variability in the in-person, but you see the same general trend holds too. And so right now where we're at is we're trying to select students to interview. Of course, if we can get students from this section to interview, that's kind of ideal. But we're kind of struggling right now with low response rates. So yes. We do. It's not shown on here. Well, actually, I don't know if we have withdrawal date. Oh, we do. Yeah, but it's not shown on here. But yeah, that would be interesting to look at too. So this is where we're at currently. I'm just starting to try to interview students, but yeah, again, we're kind of struggling with low response rates for student interviews. So open to any suggestions. That's something you have to talk to Dr. Morlock about. Yeah. Yeah, so I didn't talk that much about them here, but we're asking them a lot of questions just about their overall experience. So, how much control do they feel like they had in the course? How do they feel like the professor cared about their success, stuff like that. Things related to their motivation.
Do you have a specific theoretical framework that you're using to guide this question?
We do. So we're following the music model of motivation, but yeah, Dr. Morlock might have more to say about that. Dr. Salvador.
This is a nice way of looking at comparing the book grade versus.
Yeah.
I'm wondering what I see if I do it for all the classes, even during the normal semester, comparing the usual GPA of the student.
Right.
That kind of stuff.
Yeah.
And also if their overall GPA, if the majority of the courses they've taken, I'm assuming are paid to take, not online. And so this is where you kind of tease out the difference.
That's kind of what we're trying to do here, right? Is to kind of tease out that, yeah.
And if we just, I don't think we could have that kind of population here where if somebody had taken a majority of their courses as online and they took one face-to-face class, this would be reverse.
Yeah, that would be interesting. Have to think about that a bit more. Yeah, super interesting. I can bring that up to Dr. Ramasamy, and yeah, we'll see. He's just interested in summer courses, so we're kind of just following his lead. Yeah.
Do you think this kind of, just you're taking a guess, right? You know more about it. I do. For great majority of college classes that you're going to see the same trend, there aren't going to be like some, but for some reason they're going to do way better online.
Yeah.
You think that's possible? Maybe not.
Yeah. I think so. Yeah.
I think that's part of what we're trying to answer with the second part of this study, and with the interview portion of this. It's like, we're assuming, so these graphs help us figure out that it doesn't seem to be an instructor specific trend, doesn't seem to be a course specific trend, doesn't seem to be a semester specific.
So we're kind of trying to eliminate those factors, and then
So we're assuming it's probably something related to the design of the online course aspect itself, or perhaps student readiness to it. These interviews will help us figure out, isolate which of those factors are impacting students' needs.
that's part of what makes it so complicated, right? Is there's so many factors that could be leading to these disparities. But
You're asking what else they're doing over summer.
that's not on our interviews, but yeah, would be. Yeah. So I've only done one interview so far, and that kind of stuff does come out. So yeah, it's interesting to consider. So that's where we're at research wise. I'll transition here just to talk a little bit about my experience teaching static. Yes. Oh, no problem. Yeah.
Statics online versus courses, more interactive discussion made with project focus.
Yeah. So that's a good question. And so the two courses we're looking at here, I kind of blanked out the names here, but they're basically statics and fluid mechanics. And I think those classes are very similar in terms of material heavy. So yeah, that would be an interesting question to look at. Like, does this trend clearly exist between these courses? Would that still hold in maybe a different class, one that's not so? Yeah, exactly. Yeah. I don't have a good answer to that, but would be super interesting to look at. These are all summer.
Because I noticed like
Yeah,
Have internships in the summer and they try to do the classes at night and I.
yeah,
The time frame is about half a regular semester.
Right.
They have no idea. Then all of a sudden they wake up and go. "Oh, this is really bad.
yeah, completely agreed. And in the one interview I've done so far, some of those have come out. So curious to see if that holds in other student interviews too. All right, yeah, so hopefully you guys all found that pretty interesting. I just want to talk briefly about my experience teaching statics. I was fortunate enough to be allowed to teach a engineering statics course. I worked in structural engineering for about 4 years, so Dr. Burgessson was nice enough to let me teach a statics course. I taught to a group of 23 students, so just about half of a normal class size. It was Monday, Wednesday, Friday, 8 to 8:50, pretty bright and early in the morning. And rather than just, talk about everything, because I could probably talk about my course, for an hour, I want to talk about one specific thing I implemented. And I called these Friday review days. Essentially how these worked is did just normal lecture, Monday, Wednesday. And then on Friday, students would come in. It's almost kind of like a kind of flipped format, but not really. They'd come in and work on a packet of problems, which is basically just a review of everything that we had done on Monday and Wednesday. And part of the reason I did this is, I'm interested in flipped format, of course, but I didn't really have time to make a whole flipped curriculum. We also know that things like self-paced learning, a lot of problem solving and in-class review, these contribute positively to student learning. And overwhelmingly, I'd say I noticed that students enjoyed this, not just from interacting with them, but also in my end of course evaluations. I had a lot of positive comments, students saying that this was, they thought this helped their learning and this contributed positively to their learning. So I don't know if this is something I'd, consider going forward, but I'm kind of curious to hear from all of you also, like, what are your comments on this? Why do you think this worked or didn't work? Maybe you think it's a terrible idea, whatever, but yeah. And yeah, so my overall, experience with the DEEF here, I think it's been invaluable, not just as a learning, but all the hands-on experience. Being able not just to teach a course, but actually to plan a course. I have, say, a lot more respect, I think, for all of you guys. I knew it was going to be a lot of work. I didn't know it was going to be this much work. My whole semester was spent planning my course. And having the opportunity to do qualitative research, I think, has been invaluable also. I'm a quantitative engineer, so it's good to, kind of step outside of that. And I get tired sometimes of doing thermodynamics all day. And then, of course, just wanted to give a special thanks to Dr. Morlock for being such a great mentor through this whole process, Dr. Ramasamy for funding this research, Dr. Fairman, who's fortunately not here, but he allowed me to come into his course over the summer, serve as a TA, so super helpful. It's been a while since I've taken statics. And then thanks to Dr. Savadati too for giving me advice on what to do when students don't show up to tests. And yeah, so with that, I'll end this here. And whoops, didn't mean to do that.
I have a question on your Friday.
Yeah.
Reviews, so it's an 8 o'clock class, which like teaching. Did you make that required?
So
Did you take-
I did not. I didn't, and that's something I would change actually, because
that you talked about it, those are the ones that.
yeah, it was like exactly. So I would take attendance in the future, because what ended up happening is I get the same group of students showing up every Friday, and those were also the ones that. Yeah, exactly. So that was actually one of the things that made me hesitant about, wanting to do this going forward. Because that's difficult, right? I mean, I'm giving up a kind of a lecture day. So I'd say I tried my best. There were topics that I had to exclude. That's part of the reason why I don't know if I'd continue this. But then the comments I got regarding it were, students seem to overwhelmingly enjoy it. So, yeah.
So one of the things that I encourage students to do in the Dean's Fellowship is called backwards design with their course, where they essentially start by designing their course outcomes and then prioritizing them based on what are the most important outcomes to the least important outcomes. And rather than structuring it, in the order that it would be in a textbook, the topics are covered in order of most important to least important. So essentially it builds in time for that extra practice where students need it most. And then if stuff at the end of it ends up we not having time to cover those last topics, those are inherently the least important ones because we've organized it that way. And so students end up with a strong foundation, not necessarily complete full coverage of every single statics topic they could have covered, but they'll be able to go into future classes having a strong grasp of statics and be able to fill in those blanks as needed.
Yeah, so I'm still undecided, if I did teach statics going forward, whether I'd continue that or not. I don't know yet. Need to do a little more thinking. Yeah. Yeah, Dr. Salvador.
Talking about the general process,
Hmm?
both you and John. So when we support for the first time, the second time.
Yeah.
But this, at least for me personally, I felt that the second or third time that I've got a course is perhaps the best time that I've got it. So I've gone through it once, I've made all the various decisions, find out the things, and I'm still very interested in the things that I've got it.
Yeah.
That seems to be a bit of a weakness with the team. That is, put in all this work to teach it once, and then you don't teach it again. I would have been so frustrated.
I hope to see, the DEEF scholarship, because I think for doctoral students, right, teaching is just so important. So I would hope to see, the DEEF maybe extended or expanded. Yeah, but
So currently, it's becoming a little more common for Dean's Fellows to teach courses after they complete the DEEF. So the way that you're familiar with, we designed a TA supervisor handbook that's now become a college policy document. And in there, it outlines who's qualified to be an instructor of record for graduate students. And essentially, it's either students who have a very clear and documented mentoring plan from their supervisor during their first instructor of record experience, or someone who's taught as instructor of record before, which means that anyone who's done the DEEF before is qualified to teach as an instructor of record again. So Josh is actually hoping to teach statics again this coming spring. Andrew, I believe you said, yeah, Andrew's teaching Info 2000, the course he taught during the DEEF again next year. We've also had 2 other Dean's Fellows who've gone on to continue being instructors of record. So I 100% agree with you, Sid, and it's something that is actively changing in our college, and I think that's awesome. Yeah.
well, and I think that, yeah.
They've got that additionally.
Well, that's part of the reason why Dr. Burgessson allowed me to teach statics.
To hear you, this could be an additional or modification that will even that additionally. Well, here, this is the thought.
Yeah, there's no reason someone who has taught an industry can't also be a great teacher, but I don't think necessarily just teaching an industry automatically qualifies someone to be an instructor. And so I still want to see that mentoring plan in place to make sure that the teacher side of it.
John was helping me, Dr. about his exams.
That was strength of materials.
It's extremely meticulous. I was paying attention to everything. I hadn't had strengths in so many years that if anybody had a question, I said, well, here, talk to him or something. His paying attention to detail was phenomenal. I just wanted to comment on that. Just at proctoring that exam, I saw how diligent and how much he was paying attention to everything.
Thank you.
And those things there to help me.
Well, thank you, Dr. Yoder. Yeah, I appreciate that. I guess if no more questions, give it over to Andrew.
All right, wrap it up.
Yeah, thank you all.
And Josh will be continuing to work on that research project he talked about into next fall. So hopefully we'll see an update on that with some more interview data. Next time. All right, everyone. Hope you enjoyed the briefing. We're going to move forward with our other Dean's Fellow, Andrew Rukangu. So quick round of applause for Andrew.
Thank you, Dr. Moloch, for introducing me, and Josh left, but that was a great presentation by Josh as well. So great job. So today I'm gonna talk about the project I did for the DEEF fellowship, which it's a virtual reality for robot control and programming in undergraduate engineering courses. And at the very end, I'm gonna talk about the course I'm teaching this semester, which is informatics one, and it's like teaching Python for data analysis and visualization. All right, so I'll introduce my DEEF mentors. So that's Dr. Moloch over here, and I'm also working with Dr. Johnsen in the virtual experiences lab. So we do a lot of stuff with virtual reality. So they've helped me a lot in this semester, and I'm grateful for that. Okay, so for the project, the motivation, I'll start with the motivation for the project is we have industrial scale robots, and they're expensive and often, especially if you've been to the STEM building, we have a UR10 robot. If you need to get into that building, you need card access. So for students, they don't have that, free play with the robot. And how would we make these sorts of resources available to students? So that was the motivation for this. And some people have looked at using small versions of the robots for like theoretical, like teaching theoretical aspects, and then using online laboratories. But this run the risk of students not really appreciating being around a physical moving object. And so how do we solve that? So that's where AR and VR technology come in, and AR and VR can be used in conjunction with hardware to allow students to get into these immersive virtual environments and experience this virtual objects as if they were real world objects. All right, so yeah, so my question is, could we combine a cheap active learning tool, for example, a desktop robot, like a desktop programming interface, and then have that augmented with like a reinforcement step where the students work with AR and VR and still achieve the same benefits of working with that physical robot that's worth like $50,000. Okay, so based on that, we had these two research questions, and the first question was, what aspects of active learning programming activities, so working with the desktop robot, so what was motivating about that? And also we looked at the differences between the reinforcement tools, so between the AR robot and the physical robot in motivating students. Okay, so I'm showing two related works, and the one on the left, it shows like a lab that's already been done, and what they have is they have AR and a tablet. They are overlaying these visuals of for a flux experiment, and they found out that there wasn't a lot of differences between this lab and the physical lab. And then the work on the right has been done by a student in our lab, Anton, and he pretty much implemented a system to teach land surveying in VR. And so based on this, VR can be used in educational settings without a massive drop in quality. Okay, so to study the student motivation, I used the music model, which Josh mentioned, and that's what we used. So it has five 5 variables, and they allows us to measure like these different aspects of student motivation. So the first one is empowerment, which pretty much the student believes they have meaningful control over some aspects of their learning. And then usefulness is the students believe that the content is useful either right now or in future. And then success is whether the students feel like they are going to be successful if they apply the required effort. And then interest is whether the students find the learning activities enjoyable or intrinsically interesting. And care, which is whether the student believe that the experimenter cares about them and wants them to succeed. So in the questionnaire that we had, we didn't have any questions regarding care, but we asked questions about these other 4 aspects. Okay, so I'll go a little bit about the implementation. So this is the desktop robot, and we had it running on a laptop. So we have the navigation help menu, which allow the students to move between the practice scene and the task that they were going to do. So just to take a step back, the whole purpose of this study was to teach students how to program a robot. So like, okay, you go about by setting a trajectory. So you set the trajectory that the robot is going to follow, and then can you make the robot perform this task of, okay, picking a box from one point and placing it in a specific point. So we had 2 tasks. The first one was super easy. The student just start one block. And then in the more complex task, they start 3 blocks. So this image shows the more complex task where they took the blocks from like over here, and then they were supposed to stack them after programming the robot into these final positions. So this is the interface, and the most important thing I want to mention is we had the jogging interface, which is similar to what a real robot has. So you usually move a robot into specific positions, specific poses, and then once you're happy with that pose, you add it to your program. So so we have the jogging interface, and then the programming interface, which allowed the students to add their points to the program. So the program was made up of these actions in between the waypoints that the robot moved in. And then for the AR robot, the AR robot pretty much used what was on the desktop robot, like the graphics are the same. The only difference is the students visualized it on the Vario headset, which can run AR, augmented reality, and virtual reality. And so they observed the robot perform the pick and place task, which I programmed to do that. But they could also run their program on it, but for consistency, we just use one program. And then this is the UR10 robot in ISTEM building. And so some students observed the physical robot do the pick and place task. Okay, so I'll talk a bit about the study. So I had 8 participants, and 2 were female, 1 was non-binary. And for the criteria for selection, we wanted to work with first and second year students, because when we introduce students in the early years to real world problems, then it's been shown that they get motivated and the retention is high. So that's why we picked first and second year students. And also we picked students with little to no programming, like robot arm programming experience, to prevent biasing. Okay, so it was a between group study. The first group did program, both groups, the first program took part in the active learning activity, which was programming it on the desktop robot. And then half the group observed the robot in the air, observed the AR robot, and then half of them observed the physical robot. And the order of activities is, okay, so they first did the active learning with the simple task, the stacking 1 block, and then the second task, and then they followed that up with stacking 3 blocks. And then they did either the AR or VR, observing the robot do the stacking. And then we had a 25-minute interview for data collection and seeing their, just getting the questions geared towards motivation, like trying to get out, getting data on their motivation. Okay, so this is in an image with a study. So this is the first part where the students are programming it on the desktop. And then in the next slide, we have the AR part. So I'm gonna ask Dr. Morlock to run it for me. The one on the left, yes, please. Thank you. So we have a student observing the AR robots, and she's wearing the Vario headset. So if you think about it, the robot is kind of here. So in a field of view, she's observing the robot. Not really interesting because we don't see what she's seeing, right? Yeah, yeah. And then I'll go to the next one. Yeah, he didn't move at all. Maybe, yeah. Okay, thank you. Okay, I'll go to the next slide. And then this is the physical robot. Could you please play it for me?
Andrew, how long did it take you to program to do that?
Maybe 30 to 40 minutes. Yeah. Yeah, so this is what the second group observed. The physical robot group observed this one. I'll go on to the next slide. All right, so so for the results overall, we found out that the desktop robot had two major let's say categories. So the first one is the interface. So the students thought the programming interface was interesting, and this is based on, okay, maybe they had already worked on some 3D modeling software. They thought like, okay, the interface looks similar to what I'm used to. And then something like some students said it was like a game. It came in a game-like format. So like if you look at the comment here, it's I would say I was motivated. I mean, I wasn't bored or anything like that. And then it was presented in a game format. So I was just moving the little blocks around, and so that was fun. So they thought the interface was interesting. So that corresponded to the music, the interest component of the music model. And then the other aspect of the desktop robot that we saw is the structure of the activities. So like given this tool, how do you structure the activities around it? And students appreciated that they could get back to the problem and try it as many times as possible so that they could try and get it correctly. So for example, here the student says, so when I got the first solution wrong, you asked me if I wanted to try it and get it right. So I just wanted it to be perfect. So that was exciting. So they appreciated it being able to go back and get it right. And then what made me feel successful was playing back the waypoints that I set up in here and seeing them come together, seeing it all come together and work. So that was really gratifying. And this corresponds with the success component of the music model. All right, so in terms of the AR and versus the physical robot, so for the physical robot, the students were able to readily appreciate like how useful the physical robot was. Like what they did with the desktop robot was obvious to them when they observed the physical robot. So they were able to link their efforts in the desktop interface with the actions in the real robot. And here, these are actually excerpts from the interview. So my key takeaway is I still think robotics is very fascinating. And I think the things you can do with it are very impressive. And the fact that you can take something virtual and make it so efficiently and precisely done in the real world is a very cool concept to it. So you can see they are able to link the virtual with the physical. And then I think it's interesting to see, because all robots can replace humans, but it's interesting to see how it can be used to cut down time. And then they mentioned an example, like in research, instead of manually doing things, you could actually use the physical robot to pick things and then move them around. So they're able to tie what they saw with things that the robot could be useful in the real world. For the AR robots, the students they thought the experience was highly novel to them. So in this quote, I've never used VR, so it was cool seeing it. And then it was interesting seeing it interact with blocks, like not just on the computer string, and knowing I programmed it in that sequence was cool seeing it come to life. So they thought the novelty was a big factor in driving the interest in this group of students. Also, they had some students had some difficulty tying the experience with real robot. So when asked if what they did on that day would make them successful in future, so one student successful in programming a robot in future. So one student said, well, programming a real robot will take much more work and will be more difficult. But I think if given enough time, I could learn how to do that. So they couldn't readily tie those together. So overall, the AR robots scored highly in the interest portion of the music model, and while the physical robots scored highly in the usefulness portion. So that's all I had in terms of the research. So I'll go on to the teaching aspect. So I'm teaching this semester as opposed to Josh, who taught last semester, is doing his research this semester. So for me, so what I'm doing is kind of a flip model. I have so first of all, the greatest thing that has been helpful for me is so I have great mentors, Dr. Johnsen, Dr. Moloch. Also, I took ENED 7010, which is preparing to be an effective engineering educator. So that's helping. Also, I have TA'd twice previously for the course. So it's not that I'm starting afresh. So that has helped a lot. And I forgot to mention, so I forgot to add a point, but another big help is I have an undergraduate helping me with the grading. So that's really helpful. She took the course when I was TAing, and she's been very helpful with that. So that has made my experience really, really good. Yeah. But the way I'm running it, I have 28 students, and so what I do is they watch the videos, and then I have a quiz on the morning of the lecture. So one day is a lecture day, and then the other day is a practice day where we work on the problems together. Like I give them an assignment, and then I help them. If they run into problems, I'm there to help them. Yeah, so the biggest challenge is coming up with assignments that are just right, like not too trivial and not too hard, and also relevant. And another one was ChatGPT. We talked at great length with both Dr. Johnsen and Dr. Moloch before the course started, and we were, okay, it's programming. It's literally solves all trivial programming problems, right? Like how do you then figure out whether the students are learning or not? So the solution for that was, okay, I allowed them to use ChatGPT as long as they are able to, if they use something that's not covered in class, they're able to explain in their reflections that, okay, this is why I use this and this is what it means. And also I had a midterm exam, just one exam to make sure that students retained the content. And the other challenge for me is human factors. So management of students, like you have students coming to you with yeah, they haven't been turning in assignments, and then the student care and outreach reach out to you, so you have to kind of be flexible with that. So for me, the human management part is a big part. Like it's you have I had to think about it. Okay.
You can't just treat them like robots.
Yeah. You cannot. Yeah. That's actually not what I imagined would be the biggest challenge going into teaching. So, yeah. And so what has worked for me is one day I had this day where I asked the students to come in with problems so that like real world problems that we can solve in class. And in my enthusiasm, okay, we did part of it in class, and then I said, okay, how about we have this as our mini project? And it turns out it was a real world problem, and it's very challenging. So as you can see, it needed like 1,000 or more lines of code. And so I actually talked to Brooke about it. I have my lab mate Brooke. I gave him part of it to start doing. And eventually I had to come up with a lot of scaffolding. So like about 600 lines of code for a total of, so for the students, they only came up with maybe 300 or so lines of code. But for me, that was a good project. Like it's not trivial, and also like it shows them, okay, this is what real world problems look like, and this is how you go around like solving it. But the scaffolding was, I thought that helped a lot with that project. And then for the submission, we use Git, which is a version control system. And so once they do the assignment, they push it to Git, and I'm able to assess it. And also once any stuff we do in class, I push it to Git, and then they pull it. So this is kind of, it just integrates this tool that they need to learn, and they just keep using it during the semester. And that obviously is, I give credit to Dr. Johnsen, who used it in previous iterations of the course. And then they have reflections to allow students to earn points if they demonstrate that they understand what they did wrong in the problem. So in the assignment, so if they say I went wrong because of A, B, C, D, and this is how I would fix it, then they get some points back. And then I introduced a personal touch by asking the students to submit 3 photos, like 3 mystery photos. And before every class, I asked the students to guess what those pictures stand for and who they thought the pictures belong to. So that has been a fun tradition for the class, and the students love it. Okay, so to conclude, I'm going to show an example reflection. I don't know if it's very visible, but as you can see, these students goes, and a lot of them are like this, so they go in depth about what they thought was different between what they had and the solution. And you can see that they actually go through the solution and are able to synthesize it and come up with the differences between what they did and what was in the solution. Yeah, so that's it. Yeah, so as you read that, yeah, that's all I had for you today. Thank you. Yes.
For them to be able to, what was it, the desktop
Yes.
system back to
The
system with the robot?
Yeah.
Did you, in Python, did you create kind of an interface? I don't know, I teach a computer programming class, I still don't know the terminology. Did you create an easy way for them did they have to learn Python to program the robot? Did you have drag and drop? Did you write a bunch of code, make it easier for them to program the robot?
Yeah.
Was that a massive project for you?
Yeah, it was. Yeah, we did all the stuff behind the scenes to allow them to just drag the end effector and just say, okay, I want this robot to go here, this point, this point, this point, this point.
And it behind the scenes wrote all the code.
Yeah, we did that in Unity, and yeah, use C# for that. Yeah, and we actually
didn't show us any of that, but that was a huge undertaking for you to just create that.
Yeah. We actually had to use use a physics engine. We had to pay a license for, because Unity's engine is not, the fidelity is not high enough. So we had to bring in AGX dynamics for that and model the contacts with friction. So it does everything with physics. So we didn't use inverse kinematics, just the physics. Yes, Dr. Johnsen.
It's like you mentioned, Andrew also got a paper published from this. No, but this answer, based on that, you get a public, you did. Yeah, it's not all, I just thought I had that idea. Yeah.
Thank you. Yes, Paul.
Thank you very much for the presentation. I just want to ask, how did you assign the participants to the different groups? Were they randomization?
Yes, it was
Randomization?
randomization. Yes. Yeah.
In
Yes.
your class, is this individual or group?
Oh,
pairs?
it's individual. It's individual, but I encourage like helping each other as long as you can explain that you understood what you're using. Yes.
And one other question, what IDE did you?
So two, we are using VS Code and Jupyter Lab. Yeah. Yeah. Thank you.
Do you have particular Python packages or libraries that you're using for data science visualization?
Yeah.
That would be useful for beginners?
Pandas. So we are using Pandas and SNS for Seaborn for plotting. Yeah.
Andrew, was this all qualitative research?
Oh yeah, it's qualitative research. Yes.
Yeah.
That's why I don't have plots.
Learn all that.
I had to learn Max QDA but Dr. Morlock he helped me a lot with that. Yeah, that was all new to me.